What happens with too many Grover's algorithm iterations? Imagine trying to find a hidden treasure in a vast maze. You use a special map that guides you closer with each step. Now, think of Grover's algorithm as that map in the world of quantum computing. It helps us locate the right answer faster than classical methods. But what if you keep following this map way past the point where it's most helpful? That's what we're exploring today. Grover's algorithm works by repeatedly applying a specific quantum operation called a Grover iteration. Each iteration acts like a turn in a game, rotating the quantum state closer to the correct solution. This rotation happens in a two-dimensional space, where one axis represents the solution and the other the non-solution states. The goal is to maximize the amplitude, or the likelihood, of measuring the correct answer. The magic number of iterations to do this is about 1/4 pi times the square root of the size of the database. For example, if you have a database with 100 items, you should run roughly 5 to 6 iterations. When you do this, the probability of finding the correct answer is at its highest. It's like tuning a radio just right to get the clearest signal. But here's the catch. If you keep applying Grover's iterations beyond this optimal point, the success rate actually starts to drop. Why? Because the quantum state begins to rotate past the solution axis. Instead of getting closer, it overshoots. Think of swinging a pendulum to for and then swinging back in the opposite direction. The amplitude of the correct answer begins to oscillate, following a wave pattern. This means the chance of measuring the right answer doesn't just plateau, it actually decreases after a certain point. This oscillation is a key part of understanding Grover's algorithm. The success probability doesn't just increase and stay there. It rises to a peak and then falls again, like a wave. So, if you run too many iterations, you're essentially moving away from the solution rather than toward it. This makes the algorithm less effective or even counterproductive. In practical terms, knowing the right number of iterations is very important. If you guess too high, your chances of success drop. If you don't know how many solutions there are in the database, it becomes trickier. In such cases, adaptive strategies can be used, where the number of iterations is adjusted based on the results obtained during the process. To sum up, Grover's algorithm is like a finely tuned instrument. When played correctly, it hits the right note and finds the solution quickly. But if you play it too long, the sound becomes distorted, and the chances of success diminish. That's why controlling the number of iterations is a key part of making quantum search algorithms work well in real-world applications like data searching, optimization problems, or even breaking cryptographic codes.